The contents covered in this PPT are: first, algorithm to convert an infix notation to postfix notation. Second, evaluation of a postfix expression. Algorithm to convert an infix notation to postfix notation. Step 1. Add a round closing bracket to the end of the infix expression. Step 2. Push a round opening bracket onto the stack. Step 3. Repeat until each character in the infix notation is scanned. If a round opening bracket is encountered, push it on the stack. If an operand, whether a digit or a character, is encountered, add it to the postfix expression. If a round closing bracket is encountered, then A. Repeatedly pop from stack and add it to the postfix expression until a round opening bracket is encountered. B. Discard the round opening bracket, that is, remove the round opening bracket from stack and do not add it to the postfix expression. If an operator O is encountered, then A. Repeatedly pop from stack and add each operator popped from the stack to the postfix expression which has the same precedence or a higher precedence than O. B. Push the operator O to the stack. Now this marks the end of if. Now step 4. Repeatedly pop from the stack and add it to the postfix expression until the stack is empty. Step 5. Exit. Now let's take an example. Convert the following infix expression into postfix expression using the algorithm given in previous figure. Now in this table we have 3 columns. First is infix character scanned, second is stack, and third is postfix expression. Now first of all, add a round closing bracket at the end of the infix expression and push a round opening bracket to the stack. Now as A is encountered and A is an operand, so it will be added to the postfix expression. As minus is encountered and it is an operator, so it will be pushed onto the stack. Same is the case for round opening bracket, it will be pushed onto the stack. As B is an operand, so it will be added to the postfix expression. Likewise, divide is an operator, so it will be pushed onto the stack. Now as plus is encountered, so it will be pushed above divide onto the stack. But as divide has a higher precedence than plus, so it will be popped from the stack and added to the postfix expression. Same algorithm can be applied to other characters also. Now as after F a round closing bracket is encountered, so repeatedly pop from the stack until a round opening bracket is encountered. And then discard the round opening bracket, that is, remove round opening bracket from the stack and do not add it to the postfix expression. Now by applying the algorithm, we can find the postfix expression. Now let's take an example. Convert the following infix expressions into postfix expressions. First part, A minus B multiply C plus D. Now A minus B is written as AB minus when converted into the postfix expression. Likewise, C plus D is written as CD plus. Now the next step is AB minus CD plus multiply. Multiply is added to the last because in the postfix expression the operator is concatenated at the last. Similarly, the second part can also be solved. Now let's come to the next topic, evaluation of a postfix expression. Given an algebraic expression written in infix notation, the computer first converts the expression into the equivalent postfix notation and then evaluates the postfix expression. Both these tasks make extensive use of stacks as the primary tool. Every character of the postfix expression is scanned from left to right. If the character encountered is an operand, it is pushed on to the stack. However, if an operator is encountered, then the top two values are popped from the stack and the operator is applied on these values. The result is then pushed onto the stack. Let us look at figure 2.1, which shows the algorithm to evaluate a postfix expression. Now let's have a look at figure 2.1, which is the algorithm to evaluate a postfix expression. Step 1. Add a round closing bracket at the end of the postfix expression. Step 2. Scan every character of the postfix expression and repeat steps 3 and 4 until a round closing bracket is encountered. Step 3. If an operand is encountered, push it on the stack. If an operator is encountered, then A. Pop the top two elements from the stack as A and B as A and B. B. Evaluate the operator A, where A is the topmost element and B is the element below A. C. Push the result of evaluation on the stack. This marks the end of fifth. Step 4. Set result equal to the topmost element of the stack. Step 5. Exit. Now let's take an example that makes use of this algorithm. Consider the infix expression given as 9 minus 3 into 4 plus 8 divided by 4. Evaluate the expression. The infix expression 9 minus 3 into 4 plus 8 divided by 4 can be written as 934 multiply 8 plus 4 divide minus using postfix notation. Look at table given in the next slide, which shows the procedure. This table has two columns. First is character scanned, second is stack. Now the postfix expression obtained in the previous slide is scanned from left to right. Now first of all, 9 is encountered. As 9 is an operand, so it is pushed on to the stack as per the algorithm. Then 3 is encountered, so it is also pushed on the stack as it is also an operand. Then 4 is encountered, so it is also pushed on the stack as it is also an operand. Now then multiply comes. As multiply is an operator, then the top two values, that is 4 and 3, are popped from the stack and multiply is applied on 3 and 4. 3 into 4 is equal to 12. So 12 is pushed on the stack. Now here comes 8. As 8 is an operand, so it is pushed on the stack. Now here comes plus. As plus is an operator, so the top two values, that is 8 and 12, are popped from the stack and plus is applied on 12 and 8. 12 plus 8 is equal to 20. So 20 is pushed on the stack. Now here comes 4. As 4 is an operand, so it is pushed on the stack. Now here comes divide. So as divide is an operator, so the top two values, that is 4 and 20, are popped and divide is applied on 20 and 4. 20 divided by 4 is equal to 5. So 5 is pushed on the stack. Now minus is encountered. As minus is an operator, so the top two values, that is 5 and 9, are popped from the stack and minus is applied on 9 and 5. 9 minus 5 is equal to 4. So 4 is pushed onto the stack. Now the answer is 4.